Hello, everyone. Thank you so much for tuning in today for our session on PostgreSQL 18 performance improvements. Today, we have a very important guest with us, Bruce Momjian, who is the current VP Postgres Evangelist at EDP. And at the same time, he is the core team member at PostgreSQL Global Development Group, which means you're going to get insights right from the powerhouse himself today. So joining him is Umair Shahid, who's the founder of Stormatics, who will be moderating this fireside session. And before I hand over the controls to the speakers, I would like to go over a few housekeeping items. This session is being recorded, and you're going to receive the recording afterwards. If you have any questions throughout the session, please feel free to use either the Q&A box or the webinar chat, and we will address them in the Q&A segment at the end. And of course, we have a poll that will be shared as well during the session. So keep an eye out for that as well. Over to you, Bruce and Amar.
Thank you, Annie. And Bruce, absolute delight to have you over. Thank you so much for taking the time and joining us. I must say, I really appreciate your evangelism. I think that being around in the Postgres space for as long as you have been and continued evangelism around the world, I don't think anybody in the community comes even close to the amount of effort that you put in. I really appreciate it, and I'm really glad that to have you here speaking to us about this brand new release that we have.
Yeah, I enjoy
So
doing it. Thanks.
yeah, yeah. So yeah, Postgres 18, it's been out almost 2 months now. We're closing in on 2 months. Exciting release. Well, a new release is always exciting. I think that we've been averaging more than 150 new features with every major release that have gone out over the past many years. So, every new release that comes out is massively improved from the previous one. And there's so many new features, but what we would like to do is zero in on the features that focus on performance for this session, right?
Yeah,
So
this release count was a little high, actually. Usually it's 170, 180. This one, I think 206, which was on the high side. It's kind of interesting.
yeah, so even more exciting, right? So now, my first question to you, somebody just upgrades to Postgres 18, no change in anything, not the application, not the configuration, nothing, just an upgrade. Will they see an improvement in performance?
Yeah. Yeah, they certainly will. We really try to, if we can make an improvement, it's invisible to the user, that's a win all the time. Yeah,
Yeah.
we have discussions a lot of times. People come along and they're like, well, we want to make this optimization or that optimization. And we always try and do it in a way that's transparent to the user. But if it requires somebody to do something to take advantage of the optimization, it becomes much harder to justify because every additional API change that you make, or hey, try this thing, 1% of users are going to try it. And so you're kind of like, okay, now we've cut out 99% of our users who aren't going to try this thing. Is it really going to make that much of a difference? And if it doesn't, and it's not worth the extra code or the extra documentation, we kind of skip it a lot of times.
Okay, interesting. And so it also is interesting that no code change and just an upgrade will move the needle. It just makes
Yeah.
the overall thing go faster. It's just an upgrade. And maybe there are features in there, and we will touch on some of them as we move forward. That with a little bit of change, you can actually move the needle much
Yeah.
further.
Somebody did I think Thomas Mondo did I think a 10-year analysis of, I took the same benchmark and just ran it default for 10 years. And I think I think it was an 8 to 12% improvement every year in that
Wow.
benchmark, basically saying, all right, you didn't change anything, but this got faster, that got faster.
Yep. Yep. No, I did see that, and I think that it's very interesting that again, year over year, between 10 and 15% means that every 5 years it's kind of doubling in performance. Every
That's
five to
probably
7
true.
years.
Yeah.
That's pretty phenomenal. pretty phenomenal.
Yeah. Now, I mean, you can suggest that we were idiots and the fixes we're making, should have been fixed a long time ago. I don't think we're idiots. I think these are basically architectural changes that um, we just didn't think of, or we didn't realize the impact of. There's about a lot of cases where I look at a change and I'm like, is that really going to do anything? Is that really going to move the needle? MemoWise was a classic one from years ago. There seemed like so many criteria had to be present. It was an automatic feature, but it was so
Mhm.
many criteria that needed to be present for it to be activated that I didn't really think it was going to do much. But once we released it, yeah, we saw really a big bump from a lot of people saying, "Hey, this thing went just 10 times faster," or whatever. Um, so that was yeah. Sometimes you can't anticipate the
Yeah.
impact of something.
Also, I think that as the adoption of Postgres increases, we get exposed to more use cases, and we learn more about what needs optimization, because the community cannot think of absolutely every use case out there. Right? I think that the adoption also kind of triggers some of these improvements.
Yeah, and we're definitely getting into larger and larger data loads. We're getting into more data warehouse style queries, and how are we going to handle those? And so yeah, we just keep every year we're chipping away at that big monument.
So, with that, let's dive into, one of the most talked about features in this release, and that's, asynchronous IO. So, let's start from the basics. What is it? What does asynchronous IO mean?
So our design philosophy from the beginning has been to be as operating system agnostic as possible, meaning that we push as much functionality to the operating system as we can. So we've relied on the operating system to do prefetching of prefetching of blocks, and so forth since we began. Now, there is an API you can give to the kernel to instruct it to prefetch something. So that capability we've used for a number of years. But there's only a limited number of cases where that actually becomes useful, particularly in things like, uh, well, vacuum would be one, bitmap index scans would be the other, where we know ahead of time what we need. But um, Andres Freud from Microsoft really took on this monumental task of not relying on the kernel calls for async IO anymore, and actually building our own async IO machinery, and machinery that we can do a lot more with than we could with the simple kernel calls. So what you're seeing now is basically that initial implementation of creating basically an asynchronous IO worker set, which can basically pull in blocks before they're actually needed by particular backends.
So let's say, I'm a user that's running a data warehouse kind of a workload. How would I how would I best leverage this brand new feature? And what levers do I have inside of Postgres for tuning and optimization?
Well, data warehouse is going to use a lot of bitmap index scans, so those would definitely benefit. You can tune the number of workers that you have. There's a couple other smaller tuning knobs that you can use. I'm not. I I think the major benefit today in Postgres 18 is not necessarily going to be seen in particular workloads, but for particular hardware configurations.
Okay.
So when we run async IO on a server that has what we call direct attached storage, so that would be a PCI NVMe style bus to hardware. We don't see a huge benefit for async IO because effectively, when a backend asks for a block, even if it isn't done with async IO, it comes pretty fast, right? So
Mhm.
we don't see the benchmarks are not huge. Now, when you start to look at a case where you're using a SAN or network attached storage, or a cloud vendor who has effectively high latency IO channels, which is typical for cloud, then you start to see AI async IO making a much bigger impact. So again, I'm not sure workloads would be, but of course, bitmap index scan would be the big one that would win right now. But I'm not sure bitmap index scan on direct attached storage would be a game changer. I think it would be a game changer in a cloud environment where you've got high latency. You may have high throughput IO channels on in a cloud provider, but typically latency is high, and latency obviously is how long it takes to get the request, the first response to the request. And when you're doing something like bitmap index scan, you're doing a lot of that request. So I think those are the cases. It's more of a, I would say it's more of a hardware platform improvement in this release that you'd see a benefit rather than maybe a workload one.
Got it. Got it. Now, interesting that you talk about cloud. And one of the things that, you could possibly do in the cloud is use different types of storage, some of them much faster than others, which means that, some of them could be more traditional in nature. I don't think that spinning disks are a thing anymore. I don't think, at least. But, are there configurations in the cloud where asynchronous IO could actually hurt performance, or you would advise not to use asynchronous IO?
Well, you can fall back to the previous method that we used. The previous method had a couple advantages, I think, in terms of how checksums were computed. I've seen a couple cases where the async IO could slow it down. I think I saw a great talk in Riga actually had huge charts. And I'll tell you that room was packed. I mean, it was just everybody was in there. Uh, and the person basically, interestingly, had two charts. They had a high latency chart, high IO latency chart, and then a low IO latency chart. You could get an idea of, in a low latency situation, what would be the impact, and then the high latency and what would be the impact. So eh, I think decoupling that IO channel from the server is a long-term goal, because again, really all it's doing is right now all it's doing is prefetching some blocks from storage that you need in some limited circumstances. But I think going forward, there's going to be a lot more work. Like there's no handling of writes, for example, right? It's all reads right now, and it's all reads that you know about. It's not sequential scans. I don't even think it's even index scans right now. It's just the bitmap part of the index of the heap where you're going to the heap in random locations. So I think there's a lot more, and of course vacuum, which does a lot of random IO when it's cleaning up the indexes, which that's that's probably where you're going to see the biggest impact, because although bitmap index scans are popular, vacuum is probably more high IO throughput necessary. So I think again, usually when traditional proprietary databases work on a feature, they kind of spend years on it, and then they just kind of release it full, and then they don't touch it forever, it seems. With Postgres, what's happening is you're seeing these incremental development, because we've got a 1-year release cycle, which is almost unheard of in the relational space. You're seeing something that's not super exciting necessarily. Yes, it helps with high latency workloads, but I think going forward, as we go into future years, where this is going to be a major improvement, because we've now decoupled that IO channel from the back ends.
And there are many examples in the Postgres world where, a feature was introduced and then incrementally over the years it got, it improved and it solidified. JSON is one example. Logical replication is another example where,
Partitioning, yeah,
when they were
replication,
introduced, it was meh.
yeah,
But
yeah.
today, the way they stand, I mean, we ran a benchmark with ingestion of JSON data, Mongo versus Postgres. And for the benchmarks that we ran, we actually saw that Postgres was performing better than Mongo, and Mongo's entire claim to fame is
Right.
JSON, right? So I think that, absolutely get your point about those incremental changes and everything. Let's do a deeper dive into the vacuum process a little bit, and primarily because what I've seen is that vacuum tends to be one of the lesser understood features of Postgres, out there outside of the community. Um, how do you see? You have already mentioned how vacuum might be able to get better performance because of asynchronous I/O. Um, in a real world scenario, let's say we have a production database where there's a lots of writes and updates, etc., happening, and vacuum does need to do job. What is the kind of impact that I would see? Again, just upgrading to Postgres 18. What is the kind of impact that I should expect to see from vacuuming?
Yeah, vacuuming is confusing because it's not traditional. Most relational systems implement their cleanup in a slightly different way. They have a tendency to be less sensitive uh, to updates. So, for example, in a traditional relational system, the updates replace the in memory or the on disk copy of the row, and then the old version goes into like a what they call an undo segment. Okay. And that's usually the way, and that's what people expect. Now, you still have to clean up your aborted inserts and deletes and so forth. And you still have to clean up uh, your when you delete a row. So if you insert and you abort in a traditional relational system, that has to be cleaned up. If you delete a row, that has to be cleaned up in a traditional system. In Postgres, we just basically roll those cleanups into the update process as well. The update also gets so it basically we're a little different only in that not in the cleanup aspect, but in the fact that updates are involved in the cleanup, whereas in other systems, it's mostly aborted inserts and deletes that are only involved in the cleanup. So they always have a cleanup somewhere, but you don't normally see it. But in Postgres, we have a tendency to make it visible to you, so that's why you see vacuum talked about more. Uh, every release has a small change in the way vacuum works to make it more aggressive, to make it more auto tunable, to streamline what it does. I kind of look at the release every year and I'm like, okay, now we spent more time on vacuum. Now we spent more time. Should we have spent this amount of time on vacuum? Is there something else we should have done differently? But then when I look at the undo segment code and the complexities there, I'm like, that has a lot of you get a lot of there's a lot of simplicity in the way Postgres does things, whereas
Yeah,
the undo thing becomes a very very complex, very easily lock contending, overflowable storage area that has its own problems. So I'm not sure we would have gained a lot, just in in trying to improve that. But again,
yeah,
yeah, we do continue to improve vacuum. I'm looking at the release notes. We don't really have like a vacuum section that I had. So again, it's kind of chipping away at the edges. It's chipping away at sort of how we do event horizons, how aggressive vacuum can be, whether we can, you know, add we have a new server variable called vacuum truncate, which controls when you can when vacuum does truncating and so forth. So again, just little stuff that we chew at. We're more aggressive at freezing, for example. Melanie worked on that one. But again, there's not it's always kind of chipping away at the edges for vacuum to me anyway.
yeah. No, I think that from the perspective of multi-version currency control, there will always be a debate of the way we do things versus the way traditionally has been done with the
Right.
proprietary databases. But maybe there are only these two examples out there. None of the other databases actually do anything related to MVCC. It's
Yeah.
just the big red versus the big blue. All- So okay. No, I appreciate you kind of diving deeper into this. Uh, let's talk about the planner a little bit, and within the planner, and most of those changes would just work. But one of the interesting features that have come out in this release is the skip scan.
Yeah.
So let's introduce the skip scan feature, and maybe in your own words, help us understand what it is and how to leverage it.
Yeah, I wish I could explain in my own words, because as the writer of the major release notes, I struggled to write this item, because I had the commit message, and I could use that, and I could look at some of the comments in the code. But when I originally wrote it, I was told, no, actually, this part's not right, and this emphasis is wrong, and so forth. And eventually, after quite a bit of back and forth, we got to the text that we have now. And what I really understood in the skip scan is that up until Postgres 18, we had some effectively hard-coded rules into when an index could be used if you didn't access all the columns of that index. So if you have an index ABC, right? If we always mentioned ABC in the where clause, that was always good. We always knew that, right? If we mentioned AB, we were good there. Okay. And we had some heuristics which allowed us to do AC. So the middle one, like you could miss the last one. That was easy, right? And we had some heuristics where you could miss the middle one. But we didn't have really good heuristics if you missed the first one, or effectively the first one or the second one, which sounds just crazy to me, right? But what effectively happened is that we had these sort of hard-coded rules where, okay, we can do this, but we can't do that, right? And Peter Gagan effectively ended up building infrastructure which is much more generic. So it'll allow you to skip potentially A and B on a C index or whatever. And the heuristics are that the columns that are skipped have to have low cardinality, which effectively means that there are very few unique values that in the skipped columns, right? So if you had, imagine you have two Boolean, and this would be crazy. Imagine you have three ABC. A is a Boolean column, B is a Boolean column, right? C is an integer or a string or whatever. Okay, so cardinality of A is low. It's true and false. Cardinality and null. Cardinality B is low. Cardinality C is huge, right? And what he basically did was that he was able to look at the cardinality of the missing columns and determine how effective would it be if we skipped looking at that column and just iterated through the unique values in that column. So again, it was a much more generic solution that I think is going to pay big dividends. And again, as you said, you don't have to do anything to get it, right? So effectively, I had to make an example myself so I could understand it. But effectively, it's a case where you have two columns, you have three columns, right? And you specify the first column and the last column. And in older Postgres, it would have trouble sort of using the index. But in the new Postgres, it actually does it really well. So that was kind of my sort of understanding of how this thing works. And again, it doesn't have to be an equality, right? It could be a greater than that made the difference. But and that's where the cardinality comes in, because effectively, if you say, between 1 and 3, well, the column may have big cardinality, but the restriction you're giving it is very small, right? And therefore, you're kind of, scrunching down the cardinality of a column that may be big into some. So that's what I'm saying. The generic stuff, he really did a good job on.
Got it. Got it. Well, that helps. That helps a lot. So, if I'm running a production system and there are indexes that I plan, or there's a strategy that I'm trying to create for indexes, um, would that strategy be impacted by this feature, or should I alter my strategy with this feature coming in?
Yeah, I don't. I think if you have, see, it's hard to say. Would somebody, I guess somebody who's really sharp may have looked at the somebody who's really sharp may have looked at the queries that weren't using indexes and might have created if we have an ABC index, they might have created a BC index just because the A wasn't present in this one case. And therefore they could get rid of, maybe if the A is low cardinality, maybe they can get rid of the A part of the index. The BC one, because now the A one would work. I think in most cases, probably most people aren't going to be that smart about it. What they're going to see, they're going to probably have assumed already that we were using an index, just because
Yeah.
most people are not, when they're writing their code, are not writing their code thinking, oh, I'm doing this in my where clause, like, oh, that's going to pick up this index. Like, just people don't think that way. They're just like, give me the answer, right? So I think the big impact is you're going to see a lot more index scans over sequential scans in these cases, where we kind of could have used it before, but we didn't. And now hopefully we do.
Yeah. I think in my experience, what we've seen is that when you create an index, the assumption is that it's going to be used. And in some
Yeah,
cases, the explain plan comes
that's
back and
right.
says,
Yeah.
it was a sequential scan. People start scratching their head, why this happened.
Yeah. 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 Yeah.
And
Yeah. Yeah.
there are probably going to be less, instances of that with the skip scan in place, right?
Yeah.
Got it. Got it. Okay. Okay. Now, another interesting feature is parallel aggregates. Um, let's talk about aggregation and the way aggregates work, and the impact that parallel aggregates would have on performance.
Yeah. So how do I explain that one? So
I don't want to put you on the spot or something, but
yeah, no, I'm thinking, because I have a presentation called Beyond Joins and Indexes, which talks about aggregates and computing aggregates. So effectively, when you are computing like a group by, okay, you basically have these buckets, because effectively you're saying A group by B, right? So for every value of A, you've got a bucket, and you're grouping for a sum or a count or average, whatever. And up until this release, those were going to have to be done. They couldn't be parallelized. So you couldn't run a parallel version of these aggregates. But in Postgres 18 now, um, we can now parallelize it, which effectively means that we can do a parallel sequential scan into workers and have them sort of create these parallel aggregates in memory and then pass it along. I'm not surprised we didn't have it before, because we have a bunch of parallelism, we have a bunch of parallel, uh, but parallel aggregates kind of require you to have that dynamic shared memory area in the middle between, so the workers can all communicate into a common area to aggregate, right?
oh,
So I think that's what this that change was. That didn't, it's an interesting one. That one didn't kind of pop up to me as sort of a big one. I guess maybe I've been doing this too long. I don't normally pop up to that. But the parallelism work, again, very similar to the other work we talked about before. Um, so actually I'm looking. So I'm looking at the release notes. I don't see parallel aggregates mentioned. That's what's confusing me. Is there a particular line item you're looking at there?
I will likely need to look that up.
I'm just looking for the word aggregate. I didn't.
Yeah. I will look that up, and I will tell you exactly which line item I was talking about.
Okay.
Let me see. So, yeah. But in the meantime,
Yeah.
we do have a poll for our listeners right here,
Hmm.
and it is about whether, of course, in order to be able to leverage the Postgres 18 features, you need to upgrade to Postgres 18, and we want to understand if there are gotchas or bottlenecks that would hold back upgrades in some of these environments that people are working in. So Annie, maybe you can run a poll and help the audience understand how to use it or how to answer.
Yeah, it has been launched. So, folks, you can easily either get the QR code or, enter whatever option you feel like. So far, change risk is winning with 50%.
We'll just give it a minute or so. And just coming back to the parallel aggregates, Bruce, I just looked back on my notes, and I think I picked it up in one of the talks that David Rowley gave at OSET 2025.
Okay.
The talk's title is "What's New in the Postgres 18 Query Planner / Optimizer." Um, but yeah, I'll go through that talk again and
Interesting.
see.
Huh. That's he's a pretty he would be the right guy.
Absolutely, yeah.
So I think people have added their votes. I'm going to end the poll.
Okay, we can.
And yeah.
Sorry, Annie, you were going to say something?
Oh, yeah, I was just going to say that change risk has got into the second position. Maintenance window has 46% vote as the blocker for upgrading to the latest release, followed by change risk, and then replication and low staff DBA or none.
Yeah, yeah. Change risk, of course. I mean, when we're talking about critical systems, it is hard to kind of, and the database typically sits at the heart of the system, right? It's very difficult to rip the heart out and replace it with something new. So, I get that. I absolutely get that. But uh,
There's also
hope,
a um sort of a post-traumatic stress disorder issue with upgrading other proprietary databases. And I think they think Postgres is going to have the same issues. Traditionally, it has not. Historically, it has not. But
yeah,
I can't unlearn what they've learned. And maybe, yeah. So I would say our releases are less risky than traditional proprietary relational systems, but yes, there still is a risk. That is true.
yeah. Yeah, and the database by itself is fairly stable and it works. I think that again, in my experience, what we've seen is that people are unsure of how the application is going to react to the new
Yeah.
database, right? And they just, it's just about making sure that the application is able to work the way it is expected to work. And some of the larger systems and some of the larger technology stacks, there would be a lot of regression tests to be run, a lot of integration tests to be run in order to be fully satisfied that this new database or the application is working against this new database. And actually, that is a nice little, a segue into my next question, which will hopefully put the minds at ease a little bit, and that's about PG upgrade. And I think that for the first time, we've started to carry forward the optimizer stats from one version to the newer version. Let's talk about that a little bit. Maybe talk about what used to happen when you run PG upgrade, and what kind of stats are being preserved now.
Sure. Yeah. I mean, as the original author of PG Upgrade, uh, my goal was to make that application as agnostic as I could to changes in the database server. So, uh, historically, PG Upgrades have been around, I guess, 15 years now, 12 years, 14, something like that. And it has very rarely required changes from one major release to another. Now, and sometimes the the infrastructure changed inside the server and it had to do something different, or we did something with some index type and those index types had to be rebuilt, not traditionally B tree, but some of the other ones. So we always had like little tweaks we've had to make. But again, the idea was to be as agnostic as possible. And with the goal of being as agnostic as possible and frankly requiring as little work as possible from one major release to another, because it's very hard to test because you're effectively testing it on the release you're about to put out. So if this is what proprietary upgrade scripts have trouble with, is that they have this huge upgrade script, but they really can't test it until people actually upgrade, at which point it's going to fail or pass. And then, you know what I'm saying? Like there's this chicken and egg problem. So the idea for PG upgrade was that you didn't want to have to, you wanted to have to change as little as possible. And because of that, I always resisted the idea of saving the optimizer stats because in the early years and even as of 5, 7 years ago, we were still making pretty major changes in how we store the optimizer stats, how the data types output, how there's just a whole bunch of changes, the bucket size and how the histograms are computed and stuff like that. And again, if you're going to be updating the way you generate the statistics every major release, then there is a logic to say that we should just regenerate them every time because when you regenerate them, you get a new stats and But I'd say in the past 5, 7 years, we've kind of stabilized uh, the optimizer stats in a pretty significant way. But I still resisted kind of doing it because it was a huge amount of work and I didn't really understand for me how to make a neutral output format that was gonna always load into the next release. So Corey Hunsaker kind of took it on. I think it took him, I want to say 14 months or something. It went on way, way longer than he expected. Not necessarily longer than what I expected, but I suspected it would be really complicated. But the one complaint that we had, and I since PG Upgrade originally written, I mean, it was written actually when you were still at EDV back in the early 2000s, like 2000. I don't know. No, no, I had written it in the late 90s as a shell script. That was before your time. And then
Yeah.
in the mid 2000s, I wrote it in C and it was called PG Migrator, and eventually we got it called PG Upgrade, and eventually it got into the contrib, and then eventually it was moved into the main tree, so it was always installed. But the complaint we've had from the beginning is that great, it can upgrade in 90 seconds or 2 minutes or 30 seconds or 5 minutes, terabytes of data. With link mode, people love it, but they're like, yeah, I love that, but my system really isn't usable until I get stats back in there. So you may have upgraded it, and you did technically, but it's not usable to me until the stats are there. So we had some tricks, like we had an incremental stats build where we'd build one bucket, I think, or no, we build one bucket, one common value, right? And then we'd build 10 common values, and then we build 100 common values, and it would kind of incrementally build the stats and allow you to get your system up and going. But it was a hack, and yeah, it helped, but it still wasn't going to be happy because people would complain. They'd say, that first hour, like our crews weren't doing too well. We got a lot of slowness because we didn't have the full stats.
Yeah.
So yeah, it was just a kind of a yucky thing that I didn't really want to get into. But Corey did it. A lot of help from him, and I know Nathan Bozart was kind of helping him along. I think he might have been the one who originally committed the patch. But it took a long, long time because of those need for need for a format that would be immune to changes in the server, because we can't be testing that import output of stats every release, because it just by nature we can test a couple cases, but historically there's going to be these outliers. So we needed something that was going to be bulletproof.
Yeah, no, I get that, but I was personally so happy to see this.
Yeah.
If I had a penny for every time I've heard a
Yeah.
customer say, "We upgraded, but the system is now so slow." Well, did you run analyze? But that's going to take forever.
Yeah. Yeah. Yeah.
So yeah, no, I'm very glad to see that. But again, like many of the features that we have discussed, this is also something that has been introduced very recently, and maybe incrementally will get better. There are probably stats that still need to be regenerated or are not preserved to the next release. Maybe help us understand what still needs to be thought about.
So one missing, this is actually related to the dynamics of our statistics system, the optimized statistics system, is that extended statistics are not dumped. And the reason extended statistics are not dumped is because it's very hard to figure out what a major version agnostic format for that would look like, because the extended statistics kind of relate to the columns and the different interplays between the different values and stuff. It's just not an easy thing to do. I don't know if Corey's even going to take that on or not, but extended statistics, I mean, we've had that for at least 10 years. But I think it was a road too far in terms of what we could migrate over and what we could make sure was going to be bulletproof. I remember discussion about extended statistics, and we're like, this isn't going to be portable. It wouldn't work right. And then also you have to imagine, what if we make improvements to the extended statistics system? And then, like, do we like imagine a case where we improve the extended statistics system, and then we have to decide, do we want to preserve statistics we know are not as good as the ones we would regenerate in the new server, right? And of course, as the data changes, you're going to get new statistics anyway. But what if the database data isn't changing? Or what if the optimizer now expects the statistics to be in a different format, and those are not in the new format because it came in from the old? So this is where this is where it gets gnarly. And I haven't even seen anybody talking about migrating the extended statistics in 19. So that might be an area where we just don't do it. And I think we output some kind of message, or certainly it's in the manual, to say extended statistics are going to need to be regenerated.
Got it. Now, say we're working on a system that is supposed to be always on 24/7, or there are SLAs for availability and everything, and they've decided to upgrade to Postgres 18, right? What would be your recommended standard checklist to go through in order to make sure that the upgrade, sorry, is successful, is seamless, with as low of a downtime as possible?
Right. So the first place I go is the release notes, because that's going to be the clearest indicator that something changed, right? I mean, there's 100, 200 items, 206 items this release, typically 180 to 170. If something important is not mentioned in those release notes, we hear about it very quickly. Now, it's been a couple years. We normally, if I'm missing something, fortunately, I hear it during the beta period and I can kind of add it. So by the time we get to final, that's a good list. I would say it's very accurate. We very rarely had to go in and say, oops, we missed this important change that is impacting users. I'm sure it's happened. I can't remember a case that's happened. So the first thing we do is if you're not on depending on what release you're coming from, if you're not on the latest minor release, you should get on that latest minor release. That would be the first thing. And of course, read all of the release notes from the current minor release to the most recent ones to make sure you get that, all the changes in your current major. So get all those done, upgrade that. Again, normally nothing changes. So let's just get there, right? Because there's no sense in trying to do more than we have to, because a minor release is just bounce the server, make sure that nothing impacts you, bounce the server, we're done. So now we're on the latest minor release. Now, if we're jumping one major release, then we just need to read the major release notes for the next major release. And since we now have a minor to Postgres 18, or we will have a minor tomorrow, effectively to Postgres 18, you would want to read the major release notes and then the minor release notes for whatever add-on you get from the major, right? And again, you're not going to see any changes in the minor. Typically, they're going to affect you. They're mostly fixes. If I'm looking at the major releases for 18, and the place I go to first is the incompatibility section. So that's right up at the top. Here's a list of incompatibilities. Now I'm looking at the incompatibility. There's actually there's very few. We've had some releases where I'm kind of cringing on the changes we make. Now the changes we make are pretty targeted and usually have a very good purpose. But if we change something at like the SQL level or something at the tooling level, that's where you're like, the alarms go off. You're like, oh my goodness, like what is this? Is it going to affect me? How do I find out? Looking at 18, there's nothing there. Like the number one item is enabling a checksums, right? Number two item, and this tells you a lot, is changes in the order that we check time zone abbreviations. Okay, so we've gone from checksums, which really shouldn't impact anything, except maybe flags that you're using during the install, to then time zone abbreviation checking order. And then the third one is the removal of the MD5 password option. Um, well, or the actually not the removal of it, the indication we're going to remove it in some way. So now we're at 3, right? Number 4 is related to vacuum and analyze and how it does inherited children. Number 5 is related to like copy from and how we handle some very obscure case with backslash period. So again, I'm feeling really good. There's another 6 of them there. And then you're going to want to read the rest of the release notes to kind of see what's there. And at this point, we're 2 months in. I haven't heard anybody have any problem. Like we're 2 months in. I know a lot of enterprises are thinking, okay, 6 months, a year, we'll think about. And honestly, that's okay. But most Postgres people have been using it for years. They're pretty much on .0 or maybe .1. I don't think anybody's waiting a year. I don't know about you, but I don't see that very often from experienced Postgres people. So the bottom line is we got tons of people on this, and we haven't seen any real hiccups at all. So what you want to do is read these release notes, and somebody who understands your code should kind of eyeball this. Like, for example, I'm looking at number 8, and it says execute after triggers as the role that was active when the triggers were queued. Previously, such triggers were run as the role that was active at trigger execution time. Now, how many people in their organization understand what that even means? I don't know, but there's probably somebody who does. And they would be able to understand, oh, this would impact me or this would not impact me. And then of course the next step is to try running, a sample app on it. And again, we don't get a lot of feedback on, oh, this broke my thing or this broke my thing. It happens, but it's very rare.
Got it. Got it. Thank you. It's interesting that you brought up that MD5 thing, and the one of the questions that we got before this session started, we got a request from somebody who said that, I want to ask this question, now that MD5 is being removed. And I'm like, I didn't know that MD5 option was being removed. And I went in and checked the release notes, and, it wasn't being removed. It's just that now
It's
we're going to
marked
be
as,
getting
yeah.
a warning message that in some future release, it is going to be removed.
And then we had some discussion over whether you could control turning off the warning message. And yeah, and we actually have an MD5 password warning variable now that you can turn off so you don't get the warning once you've seen the warning, and now you know that anyway. So it's kind of
Yeah. Because the moment
interesting.
you see something like that, the first thing that would occur to you is that, okay, there's some kind of an error going on, right? And it's only in the second pass that you see, okay, so this is just a warning for something that's going to happen in the future.
Right. And a warning we can turn off, right?
Yeah,
So
exactly.
once you're like, okay, I know I'm low on oil now. Let's,
Exactly.
I
Yeah.
don't want to see that warning for the rest of my life, until I do something.
Yeah.
So, yeah.
So one final question from me before we, turn to the questions that the audience has been asking. I am, I just installed Postgres. And I start with Postgres 18. It's a brand new system. It's a brand new application that we're building. What would you recommend as the two most important configuration parameters to tweak or at least look at out of the box?
Wow. The two of them. Let's see. Hmm. Yeah, if somebody has like 2,900 slides. I'm trying I'm trying to distill it down to something.
We're talking about your favorites. So, forget about the
Yeah,
2,900
my
slides, your
favorite would be
favorites.
shared buffers
Mhm.
and probably effective cache size. Those would be my
Okay.
two. Yeah.
Okay.
Shared
And
buffers because we don't auto size the system based on how much RAM you have, right? And effective cache size because the system doesn't know how big your kernel cache is. I have a blog entry in my 700 blog entries. It does talk about sizing, finding out how big your cache size is, and then it's setting effective cache size. And that can affect how frequently we believe index pages would be already in the kernel that we could, we can make use of. So both of them really are related to caching, which is sort of a fundamental issue for Postgres. Yeah, some people would say random page cost. Um, some people would say work mem. That's another good one. Those are probably my four go-to. Four is probably the number that I kind of hone in on as the ones that probably going to make the most impact in terms of performance.
got it. Got it. Interesting that, I was reading a blog by Thomas Warntra just yesterday. He was talking about not allocating too much memory to Postgres. And yet, benchmarks run where he said that, increasing work mem actually decreases performance.
Yeah, I have a blog entry called like the memory resource triad. It's kind of a weird title, but what it's trying to say is that you've got these three competing uses for memory, right? You have shared buffers, which is fixed. You have work mem, which is dynamic, but once it's allocated, you don't each backend allocates it independently. And then kernel, which is like the leftover. So the problem he's pointing out is that if you allocate too much to work mem, then if your workload changes, you're locked into that much for work mem. You can't change it. And then for for I'm sorry. If you allocate for shared buffers, that's fixed and you can't change it, no matter what your workload is. If you allocate for work mem, that's going to dynamically change, but you can't really control it on the fly. And the basic issue is when you underallocate in those first two, you end up with a huge amount of kernel cache. And effectively, that kernel cache can act as secondary shared buffers, and it can act as secondary work mem. And that's what I think you end up getting at. And every database has tried to handle that memory triad problem differently. The problem is, even if you get the exact parameters right at an instant in time, the next 30 seconds can be completely different. So how do you
Yes.
dynamically share something? Because the problem with the first two is once you allocate them, you can't on the fly change it easily,
Yeah.
whereas in the kernel, that's like a big pool that they can both kind of pull from.
Yep. Yep. I think that's a very important point, and I think that is significantly less understood than I would like it to be out there. Right?
Yeah.
People need to understand that better. So really thankful that you brought it up. I'll shut up with my questions. I think that the audience has quite a few. Annie, maybe you can pitch in.
Yes. So, funny enough, both of you have answered a few questions that folks were asking, like what are the breaking changes, or, is there a way to make sure there's zero downtime migration to upgrade to Postgres 18? Then we have a few more that weren't answered, so I'm just going to dive into those. Are there any specific monitoring or tuning adjustments we should make after upgrading to PG18? Sorry.
Yeah. No, I don't
Yeah.
I don't think there's anything. We have added some monitoring tools to 18 that didn't exist before, but it depends on whether that's something you need to, whether that's important to you, right? I mean, we have new monitoring stuff. There's a monitoring section. It's got probably 15 items in it. In terms of performance changes, again, we did talk about AIO a little bit, but I don't think I would change anything in there right away until I identified some kind of problem.
Oh, next question. How can we pen a SQL execution plan or make it consistent to avoid plan flips?
So we get that question a lot. Uh, I'm going to give an answer that speaker questioner may not want. Is we get this question a lot from people coming from other databases because they have experience of bad plan flips in previous uh, database products, particularly proprietary ones. We do not have the way of locking in a plan, primarily because Postgres doesn't suffer from the same problems of plan flips as other proprietary systems. So no, they're the only you can do a prepared plan, but that doesn't even really that only prepares it in the one session and it only locks in the plan after 6 executions. So really there isn't any lockable plan. Some people toy with the idea. I've seen some extensions that kind of play with it a little bit, but in general, I'd be interested to know what problem they're trying to solve. And is it a problem that Postgres has or a problem that they anticipate their old database had and they think Postgres is going to have the same problem?
Okay, thank you. Hopefully they would get it.
Hopefully it's the old
Yeah.
system. Yeah, not
I
Postgres.
think I'm just going to pitch in just a little bit.
Yeah.
One other variation that I have seen out there in the field is that people look at an explain plan and think that they can do better than the explain plan that Postgres has created, and they want to be able to tell Postgres what plan to use, right? And there
Right.
is no provision to do that in Postgres.
Yeah, I honestly Postgres is not if you love like tuning things down to the minutia, Postgres is not for you.
Yeah.
I just come out and say that it's a generic database. I was in the Netherlands once with a whole roundtable of Oracle experts, like whoever the Oracle experts in Europe were, they were in that room. And we're talking about some of the optimizations that Oracle has. And they're asking why we don't have in Postgres. And I said, listen, I said, you people, the experts, you use these optimizations all the time, probably. I said, what percentage of users actually use these optimizations, Oracle-wide? And they're like 1% or 0.5%. I'm like, okay, so every time we add something to Postgres, that's a new thing. It's got to be documented. People have to figure out whether they want to use it or not. It's got code. Code's got to be maintained, right? It can effectively be misused, right? So Postgres, unless something is really going to move the needle, it's going to be adopted by a significant percentage of users, and it's going to move the needle in terms of a significant percentage, maybe it's 6%, 8% or more benefit for those 5% of users. We're probably just going to pass on that. It's just really not something that we think. And again, honestly, and I've learned this only in the past 6 months, or I've been able to articulate it, but effectively, most proprietary databases are writing their databases for the top 5% of revenue customers. And what you end up with is an incredibly complicated database that has a lot of special cases for a lot of that 5% top 5% of the user base. But for the 95% of the people who just want a database to use, you've given them an incredibly complicated, bloated piece of software, and they've got to make it do because that 5% demanded these special features. And Postgres, because we don't have any revenue, we don't even know who our 5% are. We effectively get whatever the generic group wants. So we're much more targeted to the average user versus targeted to that top 5%.
That is a wonderful way to articulate it. I hadn't heard it articulated that way before myself. So that's wonderful. Also, another thing that I love about the Postgres community and the decision making in the community, we don't do something because others are doing it. We do stuff that will help our users.
Yeah, and we're getting beaten up on TDE for that reason right now, right? That's another conversation, and I have my own opinions on that one, but
that's a whole webinar.
Yeah, it's all yeah, exactly.
Thank you, Bruce. Next question. When do we need to run vacuum full? How can we find target tables for that?
We normally would never have people run vacuum full because most tables are going to basically settle in with a roughly 5%, 10% free space kind of spread throughout the table. And, unless you need that 5% of disk space, which almost nobody does, we just recommend they just leave it. Now, if you've updated every row in a table in one pass, then you probably have 50% free. You probably have 50% free space. And in that case, yeah, you would probably run vacuum full. There's a tool called Check Postgres. It's written in Perl. I think it plugs into Nagios and some other graphing, some monitoring tools. But what check _Postgres does is it has a specific query that it looks at your system, all your data, has a specific query that I've seen, which effectively will it will basically show you the tables that are what we call bloated, right? Where you've got too much space in some particular table or whatever. So yeah, that I would look at Check Postgres and probably see if that's something you can make use of.
I read once something very interesting about vacuum full, and I quoted to people who talk about vacuum full. Running vacuum full on your database is like tearing down your house and rebuilding it just because it got dirty.
Yeah, that is a great way of putting it. Yeah, exactly.
All right, on to the last question for this session. We have upgraded from Postgres 14 to 17 in our non-production environment. So far, we haven't detected any issues. What should we watch out for if we decide to go directly from 14 to 18 instead? Currently, we have issues with out-of-memory errors. We know the root cause of it is because of lack of partition pruning in our specific queries. But I'm trying to assess the risks and benefits going straight to 18, if that will alleviate the pain somewhat.
Can you repeat the error they had?
Out of memory error.
Oh, oh, those are not good. I don't think it's hard to know. An out of memory error, you're right, it could be anything. I don't think there's any downside of going to 18. I wouldn't say that, like, if you're on 17, odds are at the time you started testing, 17 was the most recent release, so that's what you did. But now that 18's out, I don't see any downsides of going to 18. I don't think it would fix an out of memory error. But you're gonna get a lot of other benefits that probably would be worth it.
Okay, so I know I said last one was going to be the last question,
Sure.
but there's just one more question that came in. Is PG Backtrace the recommended tool for performing backups and restores in Postgres, especially for production environments?
So I'm sorry, the question was what? Do we recommend that?
Yeah.
Yeah, so we don't have so we have PG base backup, which is more of a file system backup tool, but for managing archiving and backups, PG Backrest I think is the best tool out there. Yeah. There is something called Barman, and then there's something, yeah, that's like the other tool I hear about. But I hear the most good things about PG Backrest.
All right, then I think we can conclude the session. Thank you so much, Bruce, for your time. We are more than happy to have you as our guest. And of course, we would love to have you in the future as well. And of course, thank you, Umair, for your time and hosting this
Of
wonderful
course.
session. Folks, if you have any further questions regarding anything, especially for upgrading to Postgres 18, then please feel free to contact us. And yeah, thank you so much for today and have a great day. Bye bye.
Thank you. Thank you. And thank you, Bruce.